everyone. This is the fifth experiment of recurrent neural network. So, moving on to this experiment, we'll first import the necessary libraries as NumPy, Pandas, Matplotlib, TensorFlow, and necessary libraries. Then we'll generate synthetic time series data. We'll first take np.line space as it will create 1,000 evenly spaced points between 0 and 100, and np.sin applies the sine function to those points, creating smoothing wave like data, and data.reshape will reshape the data into a 2D array of shape, because most ML models expect 2D inputs. Then we'll scaling data by using min-max scaler. It creates a scaler that scales all values between 0 and 1. Then we will fit the transform of data. It will fit the scaler to your data and learns min and max and transform it. Next we will prepare the data set for RNN. So RNN needs a sequential input, so we must split the data into overlapping sequences. So a function that creates input sequences and their corresponding targets, then sequential length, number of time steps in each sequences, value to use for predicting the next one. So x gets sequential length, consecutive values, and y gets the next value. Then we will create sequences. Each input sequence has 10 steps, and the model learns to predict the 11th value. So x dot shape will use 990, 10 and 1. 990 samples, each with the 10 values, one feature each. Then we'll split into training and testing. Splits the first 800 sequences for training and the rest 190 for testing. The test set is used to evaluate how well the model predicts unseen data, and will build the RNN model. So sequential, it will build the model has stack of layers. Simple RNN 50 neurons, and it will use activation ReLU. RNN layer with 50 neurons, input has 10 time steps with one feature each, and then tells the RNN to output the full sequence. And another RNN layer with 50 neurons does not return sequences. Then we'll compile the model. A model as Adam and loss. So it will suitable for regression tasks like time series prediction. And then we will train the model. Trains for 20 epochs. Uses of 16 sequences per training. We can use 50 epochs also, and tracks validation loss on test data each epoch to check generalization. Then it will make predictions. Uses the trained model to predict output for unseen test sequences. Then predictions were scaled 0 to 1. This inverts back to original sine wave range using the same min-max scaler. Then we will plot the predicted values of the sine wave. So the graph shows how well the model has learned to follow this wave pattern. So this was the fifth experiment. Thank you.